Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, today we're going to start with chapter 14, exponential and logarithmic function. Let's go through the basic information about the exponential function. Here is the parent function, b to the power of x. Okay. When b is greater than 1, this means that your function is increasing. And when b between 0 and 1, this means that your function is decreasing. Increasing means while you're changing the x value, this means that the y value are increasing. And while changing the x values, your y value decreasing. So the function is decreasing. If we're going to talk about the domain, it's R because R, the domain means the x values. I could take a positive or a negative or a zero. So it's R from negative infinity to infinity. And for range, it's R positive. As you see here, it's above the y-axis from 0 to infinity. And 0 here is open because you cannot take the power for anything and the answer would be 0. And as you noticed here, we have a y-intercept at 1. Why I have y-intercept at 1? Because when x is 0, anything power 0 equal to 1. So while substitute x with 0, it's gonna give me 1. So we have y-intercept all the time equal to 1. This is in the parent function, okay? And we have also a horizontal asymptote. The horizontal asymptote means a line that the curve does not touch it. Here is it, which is the x-axis in this way. So y equals 0. Now, if we want to make any transformation on the function, which means I could make a vertical translation or horizontal translation or a compression or a stretch, whatever I want. So here is the formula for it. Y equals to A times B power X. If you want to make a horizontal translation, this means that you're going to add or subtract to the X. And if you want to make a vertical translation, so you're going to add to the whole function or subtract to the whole function k. So k here is the vertical translation, which means that you are moving along the y-axis up and down. And x or h here is the horizontal, that you are shifting along the x-axis, right or left. And a here, if we multiply the whole function by a number, this means I'm making a stretch or a compression. And of course, the domain will be the same, but the range will change. If a is greater than 0, this means my range would be from k to infinity. And if a is smaller than 0 or between 0, smaller than 0, so it's gonna be from negative infinity to k. This is the range, but the domain is still the same. Here are the basic rules for powers, and make sure that wherever you're applying the rule for powers, that you apply it when you have the same base. It's very important to make sure of this. So if you are multiplying, this means that you are adding the power. For example, here it's 2 to the power 3 times 2 to the power 4. So it would be 2 times 3 plus 4, so it's 2 power 7. Now, what if we are dividing? We subtract the power. For example, here, I have x power 5 over x power 2. So it would be x power 5 minus 2, x power 3. Anything raised to the power of 0 equal 1. Very important. Also, if we have something raised to the power, then raised to the power again. So it's power of the power, you multiply. So for example, if I'm having here x to power 2 power 3, so it would be x to the power of 2 times 3, so it would be x power 6. Make sure you understand this, because sometimes you have a misconception that you're gonna add 2 plus 3, so it's x power 5. No, you have to multiply. Power, you multiply. Okay, when you have a bracket and it's raised to a power, this means you could distribute over the bracket, but you have to make sure whatever inside the bracket is multiplied, not added. So for example, here I have xy all to power 5. So it would be x power 5, y power 5. What if I have something like this, x plus y all to power 5? Should I distribute the power? Of course, no. Totally wrong. Okay. Now, what if we have a negative power? If you have a negative power, you move it to the denominator. For example, here, if I have 1 or 2 over, let me see again here, x power negative 3. So it would be 1 over x power 3. You move it to the denominator and move the negative sign. Okay, here, what if I have the negative power in the denominator? So I will just move it to the numerator with a positive sign. Here, for example, if you have 1 over x power negative 3, it would be x power 3. Let me give you another example to make sure that you understand. Okay, what about this one? If I have x power negative 3 over x power negative 4, so it would be here x power 4 over x power 3. Okay. If you have the same base and you have an equation, b here is raised to x and b here is raised to y. So this means that the two exponent or with the two power are equal. For example, if you have 2 to the power x plus 3 equal to 2 to the power of 2x plus 5. So this means that x plus 3 equal to 2x plus 5. And you could solve for x and get the value of x. Also, we have another rule. When you have a radical. Okay, a radical here. For the radical, you have this is called the index. And if you have something raised to power here, so I could convert the radical. All the time the radical is converted to a fractional power. So it would be x, and the index all the time will be in the denominator. And whatever the power below the root, you put it as a numerator. So x to the power of m over n. For example, if we have the fourth root of x power 8. So it would be x to the power of 8 over 4. 8 over 4 equal x power 2. Last things that you have to know about exponent of powers, how you solve inequality. Inequality means that you have greater than or smaller than. So if you have b to the power of x greater than to the power of y, this means that x is greater than y in condition of that b is greater than 1. And it would be x smaller than y in condition of b between 0 and 1. What is the equation of the function represented by the graph? Do you remember that transformed function? Y equal a times b to the power of x minus h plus k, and k is the asymptote, which is the line that the curve does not touch it. At here, it's equal to -3. So I'm searching for a function that has a -3 as an asymptote or as a k. So maybe A or maybe B. So I don't know it's A or B. So let's pick a point on the graph and try to substitute it in one of them. Let me pick this point. So it's a 3 and 1. Let me substitute it here. This is x and this is y. So if I put the x here with 3, 2, 3 minus 1 give me 2. So 2 power 2 give me 4. 4 minus 3 give me 1. So yes, this is my function. What is the range of the function? Function of x equal 5 to power x minus 2. Again, here is the rule for the transformed function. 3 times b to power x minus h plus k. So this is k. And you remember when a is greater than 0, this means my range would be start from k to infinity. And if it's smaller than 0, it would be from negative infinity to k. As you see here, there is no number besides the 5, so it's 1. So a is greater than 0. So this means my range would be from k to infinity, from -2 to infinity. The graph of the function of x equal 2 times half to power x minus 1 minus 1. Okay, so this means that the k here, or the asymptote at k equal -1. So which graph has an asymptote at k equal -1? C or A. Okay, good. But I need to know the graph. Okay, you have two ways, and I prefer the y-intercept to put the x equals 0, or to pick any point on the graph and try to substitute it on the function that you have here. So I'm gonna put the x here equal to 0. So it would be 0 minus 1, I give you -1. So it would be 2 times 1 over 2 times -1, it would be 2 over 1 minus 1. So 4 minus 1 give me 3. So yes, 0 and 3. Yeah, this is my graph. 27 power x minus 1 equal to 3 power 2x. When you have an exponential equation, you have to make sure that the base is same. So I have to make the 27, or there's a relation between the 27 and 3. 27 is 3 to power 3, right? So this would be 3 to power 3 power x minus 1 equals 3 to power 2x. And power of the power, you mean that you're multiplying. So it would be 3. 3 times x is 3. And 3 times -1 give me 3. So here, now I could say that the two powers are equal. So 3x minus 3 equal to x transpose. So 3x minus 2x equals 3. So this means that the x equal to 3. Again, to solve any power or an exponential equation, you have to make sure that the bases are same. So here, 8 and 4, I could make it as base of 2. So this is 2 power 3 power x plus 1 times 2 power 2 power x minus 1 equal 2 to power 5 over 2 to power x. Right. You remember, when we multiply, we add the power. So this would be first, this is power of the power. So 3x plus 3. And this is 2x minus 2. When we divide, we subtract the power. So it would be 5 minus x. So this means that 2 power 5x plus 1 equal 2 to power 5 minus x. This means that two powers are equal. So this means 5x plus 1 equal 5 minus x transpose. So this means that the 4x equal to 4, so x equal 1. 8 power 10 plus 8 power 10 plus 8 power 10 plus 8 power 10. This is a very good question here, and this is regarding the basics. Let me explain something to you here. If I say 2 plus 2 plus 2, this means it's 2 times 3, right? But if I say 2 times 2 times 2, this means it's 2 to power 3. So the repeated addition, you convert it to multiplication, and the repeated multiplication, you convert it to power. So as you understand from here, I could apply the concept here. This is 8 power 10. The repeated addition, I convert it to multiplication. How many times you repeat the 8 here? It's 4 times. Good. Now, but I need to make it as an exponential equation, so I have to make sure that the bases are equal or the same. So this would be 2 to power 3 power 10, and this would be 2 to power 2, and this would be 2 to power x. Power 30 times 2 power 2 equal to 2 power x. When we multiply, we add the power. So 2 power 32 equal to 2 power x. This means that x equal to 32. What is the solution to the inequality? Again, we agreed if we have equation or inequality regarding the exponents or the powers, you have to make sure that the base is the same. So here this would be 3 to power 2 power 3x plus 1 greater than 3 to power 5. Then we have to check if we're gonna change the sign of inequality or not. As you see here, 3 is greater than 1, so I'm not gonna change it. So it would be 3 to power 6x plus 2 greater than 3 to power 5. Now, so let's isolate. It will go here. So 6x is greater than 5 minus 2 gives me 3. Divide by 6. So x is greater than half. Now for question 18, solve the inequality 64 power y minus 1 smaller than or equal 1 over 4 to the power of y plus 2. The same base, okay? So here this would be 4 power 3 power y minus 1. Do you remember the negative power? the negative power converted to fraction, right? So I have here 1 over 4, so this would be 4 power negative 1. So it would be 4 power negative 1, so I have to multiply the negative here, so negative y minus 2. So 4 power 3y minus 3 equal 4 to power negative y minus 2. Sorry, this is smaller than or equal. So here, let's isolate. So 3y minus 3 smaller than or equal. Negative y minus 2 isolate. So 3y plus y give me 4y equal negative 2 plus 3, which is 1. Divide by 4. So y is smaller than or equal 1 over 4. Now let's go for the logarithmic functions. The logarithmic function is the inverse of an exponential function. How do you know this? Okay, you have here a graph for the exponential and for the logarithmic. Let me try to put it in a table and numbers for you to understand. So I'm gonna here draw a table for 2 to the power x and also table for the logarithm x. So here, let's start with negative 1, 0, and 1, 3 points. We're going to take it. Negative 1. If we have it negative 1 here, so y would be half. Because 2 power negative 1 give me half. Okay, then I'll put it as 0. So 0 and 1. 1 and 2. This is for the exponential function. Let's go for the logarithmic one. Here it's negative 1 half and negative 1. 1 and 0. 2 and 1. Have you noticed something? In the exponential function, this was the x and this was the y. In the logarithmic function, I flipped or switched the x and y. That's why we're saying that the logarithmic function is the inverse for the exponential function. Okay, and also it will be the inverse for all of the properties that we're going to discuss now. So here, if I'm having something in the exponential form and I want to change it to the logarithmic form, what should I do? Logarithm means that I'm asking about the power. Keep it in your mind. So for example, if I'm asking 2 power 3 equals to 8, and I'm asking you convert it to logarithm, this is base, right? And this is the power, and this is the value. So all the time you're taking the log for the value, and the answer would be the power. So here log 8 equal to 3. But what about the base? Where I should put it? You put it below the g here. So log 8 to the base of 2 equal 3. Let me give you another example to understand more. Here I have 5 power 2 equals to 25. Here is the base, the power, the value. We are taking the log for the value. So log 25 to the base of 5 equal to 2. Okay, good. Now we have two types of the logarithmic function, increasing or decreasing. It's increasing if the base here is greater than 1, and it's decreasing if it's the base between 0 and 1, the same as the exponential function, but we'll switch it. Okay, good. Now here, do you remember in the exponential function, we were having a y-intercept 0 and 1. But in the logarithmic function, you have an x-intercept with 1 and 0. And you have also a distinct point here. If you're taking the logarithm for a number which is or equal to the base, the answer would be 1. For example, if you are taking log 2 to the base of 2, it gives me 1. Why? Because here I'm asking you, if I want to convert it, I'm asking you 2 power what equal to. So it's 2 power 1 equal to. So that's why we have b and 1, the base and 1. So we have two distinct points on the logarithmic function. The x-intercept 1 and 0, and the base and 1. Okay, good. And these are very important points to identify the graph. Also, we have asymptote, a vertical asymptote. The vertical asymptote here at x equal to 0. Do you remember on the exponential function, we were having a horizontal asymptote at y equal to 0. Good. Now let's go for the domain range. Do you remember the domain and range for exponential function? The domain for the exponential was r, and the range was r positive, right? Good. Now we're gonna switch. So in the logarithmic function, the domain will be r positive, and the range would be r, which all the real number. Why? Let's consider here log b to x to y. We agreed that the logarithm is asking about the power, right? And the power could be negative, could be positive, could be 0. So yes, the domain is, there is a range is R, because we are asking about the answer, and the answer is the range. Good. Now, what about the domain? What is the value I should put it here instead of the x? Okay, if I'm giving you here 2 power 5, or sorry, 2 power 3, it give you 8. I'm giving you 2 power negative 3, it give you 1 over 8. I'll give you 2 power 0, it give you 1. No matter what I'm asking you to raise any powers, the answer all the time would be a positive number, and we're taking the log for the value. So this means that the x should only a positive number. So it's r positive. The domain is r positive. Now when we are making a transforming function, when you are shifted up or down, this would be the formula for it. Y equal to a times log the base x minus h plus k. And the horizontal asymptote, sorry, the vertical asymptote would be x equal to h. This is the vertical asymptote. Here are the basic rule for the logs. When you are multiplying something, this means you're going to convert it to addition. For example, you have log xy, so it would be log x plus log y. Okay, if I didn't write any base here, so this means that the base is 10. Okay, good. Again, if we didn't write any base below the g for log, this means that the base is 10. Okay, also if we have the log for x over y, so it would be log x minus log y. If you have it, raise it to any power, so this means that you have to drop the power, so it would be 3 log x. And all the times the log of 1 is 0, and the log for a number which is equal to its base, it's 1. Very important rules. And if you are talking to log, for example, 2 to the power 3, the base here and the power is the base of the power also are equal. So this means the answer is the power 3. Also, if we have, okay, I could separate the log. For example, I have here log 2 to 8. So I could separate it to log 8 over log 2. This is called the change of base formula. These are the basic rules for the logs. Now, while you're solving any logarithmic equation, you have to make sure that the base are equal. Also, the same for the inequalities. Let me take an example for you here. If I'm having something like that, here log x to the base of 3 is smaller than -2, and I'm asking you to solve this. So this means that you have to convert it to the exponential form. Consider this in your mind, the smaller than as an equal. So here it would be x smaller than 3 to power -2, because we know that the answer of the power is of the log is the power. This is the power, and this is the base, and this is the value or the answer. So this means it's x is smaller than 1 over 9. But you have to make sure that you understand something, that the x cannot be a negative number. So this means my real solution would be 0 smaller than x is smaller than 1 over 9. Make sure that you understand this point. Because again, x cannot be a negative number, or the logarithm cannot be taken for a negative number. The exponential form 343 equal to 7 power 3 is equivalent to, again, we take the logarithm for the value. Where is the value? Here's the value. So log 343. Where is the base? The base is 7 equal to the power, which is 3. So log 343, the base of 7 equal to 3. Then we have x equal to the fourth root of 81. So this means x equal to 81 power 1 over 4. We're taking the log for the value. So log x to the base of 81 equal to the power, which is 1 over 4. The logarithmic form equivalent to the equation 4 power 2 equals 16. So here we are taking the log for the value, log 16, and the base is 4, so it's equal to 2. So here's the answer. The exponential form equivalent to the equation. Okay, good. Now, exponential forms, this means that its base, power, equal to value, right? So where is the base? Base is 3. Where is the power? The power is 4. And where's the value? The value is 8. So a equal to 3 to power 4. Log 1000 equal to 3. Okay, when we don't have any base, this means that the base is 10. So this means if I want to convert it, it will be base, right? To power equal to the value. Where is the base? A base, there is no base here, so it would be 10. Where is the power? The power is 3. And the value is 1000. So 10 power 3 equal 1000. Okay, here log AB equal log to the base of A, B equals C. Again, here's the basis A, the power is C, and the value is B. So A to power C equal to P. The exponential form of the inequality is, okay, good here. Where is the base? The base is 5. So 5 power 2 smaller than or equal to x. This means that x is greater than or equal to 5 power 2. This one. Question 16. What is the equation of the function shown in the graph? While you are looking for any logarithmic function, you have to check the asymptote first. Where is the line that your curve does not touch it? So here, it would be at x equal to, right? So it's in the right direction, so it would be x minus 2. So maybe A or maybe D. So I need to know. So I'm going to pick any point on the graph and apply it in the choice A or D to check which one will give me the right answer. This is 3 and 1. So I'm going to put x here with 3. So this is log 2 to 1 plus 1. Log 1, give me 0. So 0 plus 1, give me 1. Yes, here's the answer. So choice A. Question 17 is the expression log b to the power 5 to the base of b. We agreed if we have a bar, we have to drop it. So it's 5 log base b to b. If you have the same base, so this means that the answer is 1. So this means it's 5 times 1 equal to 5. Question 18 is the value of the expression log the base of 5 to 1 over 25. 1 over 25, it's 1 over 5 power 2, which means it's 5 power negative 2, right? So log the base of 5 to 5 power negative 2, I have to drop the power and negative 2. And log 5 to the base of 5 is the same base, so it's 1, it's negative 2. Which of the following is the largest in value? Actually, we have a trick to solve this one, and it's applied poorly. This logic calculations that the log would be large if b is small and a is very large compared to b. Okay, so let me see here. Here, log 91 to the base of 10. 10 power 1 is 10, and 10 power 2 is 100. So this means if I'm taking the log, this will be smaller than 2. And for the other choices, let me check. Here, 7 power 1, 7, 7 power 2 is 49. So it would be greater than 2. Here also 8 power 2 is 64, so it's also greater than 2. And 6 power 2 is 36, 6 power 3 is 216, so it's also greater than 2. So I could cancel this choice, but I need to check one of these, B or C or D. So let's apply the rule. B is small, so the smallest B here is 6, and it's a very large compared to B. So it's B. As you see here, the difference between 7 and 81 is just like 60. Here's 64. The difference here is 62. The difference here is 69. So which one has a small b and a very large compared to the b? This is choice. Okay, question 20. If log 5 for the base of 2, approximately 2.3 is then. Okay, 125 here is just like 5 power 3. Right? So I have to drop the power. So it would be 3 log 5 to the base of 2. So this means I have to multiply this times 2 power 3. 2 power 3 times 3. 3 times 3 is 9, and 2 times 3 is 6, and we have the point, so 6.9. Solve the inequality. Log x to the base of 4 smaller than -1. Okay, I have to convert it to exponential form, so I leave the x here, and it will be smaller than, of course, this is the power, right? And this is the base, so 4 power -1. So x is smaller than 1 over 4. But actually, we have restrictions that we cannot take the logarithm for a negative number. So this means that x should be between 0 and 1 over 4. So 0 is smaller than x is smaller than 1 over 4. Simplify the expression. So here we were adding, so this means that originally we were multiplying. So it would be log a power 3, and we have a power here, so we have to get it back again over the b, so it's p power 2 minus, this means that we were dividing, so log, let me erase this one, for c. So here's the answer, b power 3, b power 2 over c. Question 24, simplify the expression. Good. Now, if we have a number besides the log, this means it was a power. So it was log x power 2 to the base of 3, and here log 3y plus log the base of 3 to z power 4. And if we added the logs, this means that we originally we were multiplying. So it would be log the base of 3 to x power 2 multiplied by y multiplied by z power 4. This one. Question 25, solve the equation. Let's solve. Now, if we have the same base, so this means that x power 2 minus 9 equal to x plus 3. Now, let's solve it. X power 2 minus 9 is just like x minus 3 times x plus 3 is the difference between two squares. So if I divide it by x plus 3, it cancels. So I left with x minus 3 equal to 0. Sorry, equal to 1. So if I transpose, so x equal to 4. We solve the equation. We have to make sure that we have the same base. Here's the same base. And we have a subtraction sign here, so they were dividing. So log x power 2 minus 1 over x minus 1 to the base of 2, log 2, 3. Let me put them as an equal. And I could simplify or could factorize x power 2 minus 1 to x minus 1 times x plus 1 over x minus 1 equal to 3. Cancel. So this means that x plus 1 equal to 3. Transpose to x equals 3 minus 1 equals to 2. Which of the following represent a solution? Let me check here. Again, the same base. So, and we have a subtraction sign, so they were dividing. So log 2x over x minus 1. But I don't have here a log, right? Do you remember what is the log? Will give you an answer for 1. If you have a log with a number equal to the base. So the log is a base here is 2, so I will just put 1 as log base 2 for 2, okay? So log 2, 2. So this means that x over x minus 1 equal to 2, cross multiplication. So 2 times x minus 1 equal to x, multiply to x minus 2 equal x transpose. So x equal to 2. We solve the inequality. Let me make sure that we have the same base. Yes, we have the same base, 3 here and 3 here. So this means that x plus 1 is smaller than 2x minus 4. Let's transpose. So here 5 smaller than 2x minus x give me x. This means that x is greater than 5. The value of the expression log 10 to the base of 7. This means I have to just separate it. I have to start with the log of the value, log 10 over log 7.